Now, as before with your roots and coefficients, and I'm trying to avoid drowning in a sea of alphas and betas and gammas, these questions are really much the same, but they sort of twist and turn in slightly different shapes. Okay? So I'm going to walk you through one of them, one of the tricky ones actually, and hopefully it'll equip you enough to have a go at the others. And once you see that insight, you'll be like, oh, this is fine. It's just all different variations on the same theme. Okay? Here's a cubic polynomial. The information they tell you apart from these other coefficients is it has a double integral root. Now that's a bit sneaky because some of you may be aware the word integral has a very specific meaning in maths. It's meant to be about the opposite of differentiation and derivatives and that kind of thing. But in this case, it's just about roots and coefficients. What do you think they mean? If you had to take a guess. It's an integer. It's just a whole number, right? So what they mean is that a polynomial, right, which has degree 3, we would expect to have 3 roots, yes? Some of them might be imaginary and that kind of thing, but in this case, what we're going to have is 2 of them being equal to each other, okay? And not just being equal, but integers. So I would say, therefore, let the roots be alpha, alpha, and beta, right, where alpha belongs to this set of numbers, set of whole numbers, all right? Okay, now the question is just to find k. Now, with all of these questions, in some ways it's exactly the same as the previous type of question where you're trying to evaluate alpha plus beta plus gamma times blah, 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 blah. The way you always start is say, take your sum of roots 2 at a time, and your product of roots, just get those numbers out, okay? Now in this case, because there's a k, right, they're not going to be numbers, they're going to be equations that we're going to have to solve, right? So let's start. Sum of roots, which would ordinarily be alpha plus beta plus gamma, but in this case, that's what I've said they are. What's it equal to? Minus b on a, right? So minus b on a, there's that number. Okay, so 2 alpha plus beta, equals 5. Let's call that equation 1. All right? Next equation is taking the roots 2 at a time, right? So the first product is going to be alpha squared, right? The next one will be these 2. And then the last one will be these 2, which is actually the same, right? So that's the sum of the roots 2 at a time. Now, that's equal to, this is minus b on a, so this is c on a, so it's just going to be 7. Is that okay? All right. So I'll call that, well, let's just simplify that. Call that equation 2, all right? Last one, product of all the roots together, alpha by beta, so that's alpha squared beta. We said minus b on a, c on a, so this is minus d on a, so that's going to be minus k, right? And that's equation 3. All right, now remember, we're after k, in this case, that's what we're actually trying to solve. The fact that we've got 3 equations here is a good sign, because we've got 3 unknowns, alpha, beta, and k, all right? Basic rule of simultaneous equations, for every variable, or every unknown you're trying to find, you need 1 equation for it, okay? If you've got 1 equation and 2 unknowns, you're never going to be able to solve what they are, all right? So, if that's what we've got, what do you think we should do as a first step to put them together? What do you recommend? Any of these? Yeah, Justin.
For 1, you put the b in front, and then you sub that into 2.
Okay, good. So you can see that equations 1 and 2 are going to be good to go after, right? Because if you went straight for 3, which is actually the one we're going to be interested in, we don't know enough about it for us to actually solve anything, okay? Whereas, if I get another color, 1 and 2, right? You just consider those. You remember how I said this whole question, I've got 3 unknowns and 3 equations, right? So I can solve it. Or part of my first step will be 2 unknowns, alpha and beta, and 2 equations. So I'm trying to reduce the complexity of the problem, okay? So what did Justin say? I think he said to get this in terms of beta, all right? So bring that over here, and I guess you've got beta equals 5 minus 2 alpha, okay? Now, I could probably call this equation 4, but that's a bad idea. Anyone know why? I had to call it something, but why not 4? Because it is my 4th equation. I am actually going to call it 1a. That's what I would. Here's why. Here's why 1a is a better name than 4. Okay? 4 is just, it's the fourth equation, but it doesn't tell me where the equation came from. Okay? But 1a actually tells me, look, this is where I started up. This is my source of information. And the thing that it stops you from doing is putting this equation back into itself. Right? If you ever do that, all you end up with is a trivial statement like 0 equals 0 or 1 equals 1 because you've put it back into itself. Okay? Surprise. So now that I know it's 1a, now I know I'm going to bring it together with 2. So from here, I'm going to sub 1a into 2. And you guys have been doing simultaneous equations for ages. You guys know that you have to actually say what you're doing. You can't just have random equations just flying around everywhere. Right? So down here, what do we got? Alpha squared plus 2 alpha. Okay, now I can bring in my substitution. 5 minus 2 alpha equals 7. So expand. Simplify. Bring this guy over. Okay, now there's a quadratic. Now you look with me. What can we do with this? Can it be factorized? If I make the sign out the front a little nicer.
Yeah, it
Can it be factorized? What are we going to factorize it with?
It's like
3 alpha plus
3 alpha plus
3 alpha minus 7 and then alpha minus 3.
3 alpha minus 7.
That's
Yeah,
alpha
careful.
That's what. Yeah.
That's totally what I meant to say. Okay, now by the way, I don't want to assume if you're sorry. I don't want to assume that you're good at this. I remember personally having heaps of trouble with non-monic quadratic equations and factorizing them. There's a lot of different methods. Obviously, if you don't want to factorize, you can just go straight to the formula. It'll work, but it's kind of excessively long. You can do the cross method, but I kind of never really got that. If you like it, it's fine. Well, yeah, I don't like it. I don't understand it very well, so I don't teach it. Well, now see just do it in my head doesn't actually tell you anything about how do I do it. So okay, I'm just going to walk you. I'm going to walk you through one way. This is the way that I do it. How do we arrive at this result? Well, you remember that if I give you a simpler example. Let's call it, say, this. Obviously, the important numbers are 5 and 6, right? What do I do with the 5 and the 6?
Find the factors of 6.
Okay, so I want two numbers, pair of numbers that will multiply to that and add up to this, okay, and the numbers are 2 and 3. Right? Now, when you put a 3 out the front, or any number out the front, it's almost exactly the same, but instead of having numbers that add up to 5 and multiply to just this number on the end, okay, you want numbers that add up to the number in the middle, but multiply to the product of these two, okay? So instead of just this number on the end, you're actually thinking of 21, okay? Which in fact is what you're already doing. It's just that in this case, the A is trivial. Okay, it doesn't matter. So now you guys get lucky on this one because 3 and 7, because they're prime, right? The number you get at the end, 21, the only two numbers you can multiply together to get 21 are 3 and 7. Well, I suppose you could have 1 and 21, but that doesn't really fit with the number that you've got here, minus 10. Okay. Integers, okay? So what am I going to do with 3 and 7, they multiply to 21, but I want them to add up to minus 10, okay? So that's why positive 3 and positive 7 won't cut it, because they don't add to minus 10. I want negative 3 and negative 7, okay? So here's what I'm going to do with the negative 3 and the negative 7. I'm going to put in 3 alpha here, and then my first number, and then 3 alpha, and then my second number. But when you look at this, right, when I expand this back out, I'm not going to come back to where I started, right? So to compensate, I'm going to divide by 3, okay? So this 9 alpha squared will turn back into a 3 alpha squared, and that's equal to 0, okay? Now, if I've chosen my numbers right, this 3 ought to go back into one or both of these factors, okay? In this case, it's kind of obvious that, that 3 and that 3 alpha minus 3 turn back into that, okay? But that's one way. I like it because it's very similar to what you're already doing. You just have to modify it a little bit and take into account both numbers, okay? Right, let's come back to the question. Alpha, therefore, is equal to? Right, okay. So now what?
Alpha is supposed to be an integer.
Good. So just come back to what the question told you, right? As alpha is an integer, okay? Therefore, it's equal to that. All right. Now I can probably finish this off. In fact, I will in a second. But do you see that's the critical part? Working out what your equations are and then how you're going to fit them together. Once you've got one, it's like a set of dominoes. Okay. I'll go ahead and put the working there, but I can pop this back into equation 1 when I've got alpha and beta. Then I'm just going to pop them to equation 3, and I'm home and host. Okay. Does that make sense? Any questions? All right, just for the sake of it, and because I haven't given you answers for this sheet, I might as well go ahead and finish this off just so you can verify that the answer is correct at the end. Okay. So if I sub this into, I'm going to get 2. So I've got 1 squared times 3. Finished. Okay.